Good afternoon, everyone. I would like to discuss the phenomenon called superconductivity. It is one of the Nobel one theory, Nobel one concept, and which is explained by the quantum physics. And today's of my lectures are like this, and then BCS theory, and then Meissner effect, and then magnetic material, and of those concepts like that BCS theory, Meissner effect, and then magnetic materials and applications. So now discuss that what is the physics behind the superconductivity. What is the superconductivity now? The superconductivity is the phenomenon in which certain materials loses its resistivity. I mean the resistivity is completely becomes zero at critical temperature. At certain temperature, that is called critical temperature, and those materials are called superconductors, and then that phenomenon is called that superconductivity. So how did you get that superconductivity from the materials? Is it right? So some of the materials I choose material should be what below that critical temperature, and at that moment I took that two electrons and then one lattice ion. So electrons has that negative charge, and then lattice ions has a positive charge. In physics we can call that lattice ions as called as phonons. These are the two electrons we can consider. These two electrons has that opposite spin and then opposite momentum, which means that they are moving in that opposite directions, and beside that lattice ion. So these have that homogeneous charge. Because of that homogeneous charge, these are differ from each other, and then Coulomb repulsive force is created between the two charges, and then attractive force which is created between the two electrons as well as this lattice ion, which one we can consider the lattice ion in the material. At that moment, the Coulomb attractive force has been controlled. At that moment, these two electrons are forms a pair, and then that pair is called that Cooper pairs. These two electrons are forms a pair that is called that Cooper pairs. This Cooper pairs is produced at what below critical temperature. Then only it is possible to produce that. So at critical temperature. So now I will come to the conclusion. At critical temperature, at below critical temperature, I took the two electrons has opposite spin and then opposite momentum, and these are controlled by that what lattice ion beside these two electrons. So what is the force which has created repulsive force in between the two electrons, and then Coulomb attractive force between the electrons pair as well as this lattice ion is much more, so that the Cooper pairs are produces, and these Cooper pairs are encounters all resistance present inside the material, so that the superconductivity becomes infinite, and then resistivity becomes completely zero. So this is what the science behind that. So now I will like to discuss that Meissner effect. What is the Meissner effect, and what is the applications of the Meissner effect? So now I will consider the one of the material here. So that is a normal material, and then this material should be more than that of critical temperature. When you are applied the magnetic field lines, these are the magnetic field lines, and then when you are applied the magnetic field lines to the body, they are printed to the body, and then they are coming out from that. So in the second figure, I will consider this is the superconducting material, and that moment this superconducting material is below that critical temperature. When you are applied the magnetic field lines, which are expelled from the body, and then they are coming out from that body. Okay, this is which means that this superconducting material acts as a perfectly diamagnetic material when you are considered the temperature below the critical temperature. Is right? Below the critical temperature. So this is what this Meissner effect. How this Meissner effect is applicable to the what different applications, we'll come to know that. Okay. Applications of Meissner effect, I mean the superconductivity applications. So here this video which shows that what is the Meissner effect, how does it works, and then how does the magnetic trains are working. So for that we should look at this video which explains that everything about that magnet, and we should apply the magnetic field. This is the one of the metal, sorry, this is one of, on that we should place in some of the materials, the superconducting material, this one, and this is one of the superconducting material. This is a black material. Using some phenomenon, we should create the magnetic field around the black material. Here, this is the magnetic field which is created here, and we should take that one material, that is our superconducting material, this one, and place it on that. Due to the enough forces, repulsive forces is created in between the black material and this material and this superconducting material. This is the superconducting material. So there is an enormous gap which is created because of the enormous repulsive force which is created between the superconducting magnet as well as this superconductor. So that, which means that magnetic train is present here. Is that right? This is what magnetic tracks. At that, after some time, when it is magnetic train, this is, look at here. This is due to the what, the force, enormous force which is created, repulsive force which is created in between this one and this one. This is the gap is there, right? So here there is a repulsive force which is created between this black material and then superconducting material. So after some time, so magnetic field which is what disappeared. So therefore there is slowly comes down and then placed on that. So this is what the Meissner effect.